This double bill episode of The Octopus compares two image recognition projects. German artist and academic Christian Sievers talks about his art project World Instance, based on ImageNet resources, and Kenyan coder and neural network expert Brian Muhia discusses his application Shambabot, which identifies plant illnesses. These two image-based projects are contrasted with the work of Stefanie Glauber, an artist who employs neural networks to experiment with the world of odors and scents. Our discussion floats along and peacefully orbits the different layers of recognizing, understanding, and interpreting of sources and data through machines and different senses. On the way, we touch down on the art scene's favorite perfume, Molecule 1, but also the challenge of working with different images produced by a variety of mobile phone cameras, human bias, and homogeneous groups of humans operating in specific areas of our societies, collecting art and smelling machines. And also we managed to cover in quite detailed technical discussions about how image interpretation and neural networks work.
Octopus.
Hello, this is a new edition of The Octopus, the podcast from the Black Mirror Institute and the Academy of Media Arts in Cologne. Today's guests are Stefanie Glauber. She's an artist in the field of technology and science. You're a former student at the Academy of Media Arts, KHM, in Cologne. And today I think you will talk about odors. We have here Christian Sievers. He's an artist and he's working in the field of surveillance architecture and also works with facial recognition technology, installation, but you will also talk to us about that.
Yeah.
And then from Kenya via Skype, we will have Brian Muhia, and he's an optimist and a technologist from Nairobi. And he works in the field of image recognition and AI. For example, he created an app where plant illnesses could be recognized, but he will later on tell us about this. So, let's go into the discussion. The topic today is recognition. Is it recognition? What was your thought, or why did you propose this topic for us today?
I think we got into talking about an artwork of mine, a recent artwork, which is using a visual pattern recognition algorithm that I just downloaded and used and applied for this artwork. And then we got talking about recognition, and I got really romantic and saying, oh, you know, this moment when you're freshly in love and you haven't seen your beloved for too long time, and then suddenly you see her or him, whatever, you know, in a group of people. And it's just a physical jolt, you know, that goes through you. There's a certain something happening in you. That's recognition. It's not a neutral thing that you just do, but it's very active and it does something to you. I'm quite romantic about it.
Mm-hmm. Steffi, what is your current obsession?
I started having the theoretical idea about creating an object which in real time smells like me. So, and for this I had to dig into odor detection, discrimination and diffusion, and found things which I found very interesting because I have never thought about odors in general before, because it is not usually my kind of interest. Except maybe I have many friends who are very into perfumes. They started to spend a lot of time on online forums where people have their own private collection and start to use special perfumes before going to sleep. Also during the day, using different ones. Also aspects of layering perfumes. There are some, and also very often to be found in art contexts is the Molecular 1 series by Gesa Schön. One item, and this is Super, which is a very classical item of almost all other perfumes. I guess about 80% of all people you smell in art galleries use it. If you go deep into perfumes, there's so much to find, like basic notes, middle notes, high notes, when do they appear most significant. I think layering is definitely a form of personal statement, of personal interest.
Is it used to identify and be part of a group, for example?
If you look into which people buy which perfumes, you will definitely find similarities. So if you check out who wears Paco 1 million Gabbana, like that's like you but
the golden one is
the golden one, yeah.
So who wears that?
Like if you go into a fitness club, then and then you'll if you smell the mainly the guys who walk out of the washing room, then there will be a lot of Paco.
Oh, I go to the gym. It reeks inside the room. It's amazing. So you're doing an odor mirror. So you how is your smell being picked up, and how do you reproduce it, and what is the function for you? Is it a public thing, or do you do it for yourself?
No, it's meant to be a work of art.
Okay.
Maybe to be bought. Yeah, I mean, for me, it was interesting to see whether it does translate and whether the form of me just kind of is projected on this object. And I choose this object to be super technical. It's just a Raspberry Pi and a odor stick. So I used a form which does not at all has any easy way to be projected, like how I look, which was very hard because I thought about, what do I do as a visual form for this object? But when I thought about having a kind of human-looking like thing, that really gets kind of unangenehm for me.
How private is the smell? I mean, because is it okay if you go up to someone and smell the person? I mean, how close can you go? On the street, I pass someone and I do smell the person. And sometimes it's not necessarily perfume, it's just the smell of the person.
Yeah, I think that's very culturally different. So I just can speak about my observations mainly here in Germany. But it is private, super private. The lack of words we have for describing how something smells shows how much of a taboo it is or was. So we just have words describing how the source smells. So it smells like flower. It smells like rainy day. It smells like, I don't know, tobacco. But we have very few words to describe a scent, an odor, not referring to anything. Usually just good and bad.
And good or bad is in the nose of the smeller. You know, it's in the eye of the beholder.
It is subjective, but not only. It is subjective, yes, but not only, because there are patterns of how people smell, and they are very unconscious. I needed to start to smell perfumes to know that all the guys wear Paco Rabanne, or I needed to go to smell Molecular One to understand that all the art people wear Molecular One. So before that, I didn't know that. There are patterns, and this was interesting for me in doing this artwork. As patterns are very easy to be, or are very often used to get monetized, I thought, well, I need to get into the thing to get money out of detecting odors.
We'll cycle back to the to the part of recognition in terms of smell, and also to the political or socio-political dimension. And maybe we go to you quickly. The project you did with facial recognition or whole body recognition.
It's object detection.
Or object detection, exactly. Tell us about it.
I'll just describe what it looks like when you come in. It's basically one large screen, and there's a camera in the middle of it. As you walk up to the screen, you see yourself. It's just a live camera image, a CCTV setup. Plus, you see whatever it is that the algorithm makes of the image. And because I'm using just a found system just of GitHub, basically, it just looks like they always do. You know, the algorithm draws a frame around whatever it is. It recognizes and then writes the label on top, which is a sort of standard way to run it, and I didn't change any of that.
Where does aesthetics comes from?
The framing.
Yeah.
I think framing is old, as marking the difference between this is important and this is not. And I'm using a detection system called YOLO, which is a pun. But this is called, it's a variation as you only look once, because it was made to be really quick. First, it was made to be really quick, and it just needs one frame. And this was a special version of it that has been trained to recognize more than 9,000 different things. And it's based on ImageNet. And I think Brian has also made work using ImageNet. ImageNet is one of the oldest image data sets that exists, which is from I think about 2008 or something. And it was really conceived in California and then, made around the world by, I think, Amazon Turkers. I think they just took images off the internet and annotated them. So you walk up to the screen, you see it yourself, and because it reinterprets every frame, you get lots of information. So 1 second it sees you as just person, which is a sort of very common thing, and then it says traveler or businessman, or it will give an ethnic description of you suddenly for some reason. I wanted to make art from it, and of course you can just set this up, but instead I expanded it to also save the images that it gets in the terms. So it has these 9,000 things that it can recognize, but I expand it in such a way that every time it sees anything for the first time, it saves that image into a database. And also where it is in the hierarchical tree and so on. So if you walk up to it and it says you're a soldier, you will be soldier in that database forever. So you can't just intervene and say, I don't like this. It will just do this. So I guess it's by walking into the space, you agree to
interfere. So you nail it on the "you only look once" wording.
Yeah. It makes decisions. It's really it's a really aggressive decision.
Yeah, but
system.
you nail it, because if you wouldn't choose to just nail it to the first image, it would have like hundreds of description. But you say no, stick to your name.
That's perfect. You're right. I didn't think of this. But so the idea is that it builds an encyclopedia of the world, like a new instance of the world, and that's why it's called World Instance. So when you turn it on and it starts to look at the world for the first time, of course it finds many things immediately. All the low hanging fruit. And then nothing new comes, and just the same. Like you said, people look the same mostly, and especially in art circles. It's really scary. And also it's a problem for this system because it runs out of new things. But anyway, after 1 or 2 days, it starts slowing down. It has slowed down already, and of course, it still makes misinterpretations, and then you start to get the really strange stuff. So you have a picture of a woman who's kind of kneeling down on the floor, and her long arm looks like an elephant's Rüssel. So suddenly it says elephant, or like some scientific name for elephant. And you get all these other things which are really insulting, really terrible things it says about people. And that's the idea, that you just subject to it. If you want to play with it, you have to agree to be judged by it.
We used the word recognition. So there is different categories to it, right? So there is kind of the technical recognition that this machine does, but first of all, the machine is very insecure. It doesn't really know, and it doesn't really know whether that is. It's just a probability, and it's not a fucking elephant, but it looks like an elephant. So there it gets interesting, I think, especially when you then also look from here to odor, for example, which is much less, because the visual is so well described. Mm-hmm. We have words for everything, for colors, for forms, for everything. So we have a very highly developed linguistic way of describing. But in odor, we don't have that. So basically, here we have two positions. That this is a very established position that is playing around with what is now a contemporary issue, a real issue. And you're playing around with the stepchild that is somewhere hidden out and doesn't get the funding.
But also trying to understand where it already gets the funding, or in which step it already is, and it's not so easy to find out, really.
The thing about smell is that I think for most people it's a very emotional thing. I think everybody gets this when you smell something from your childhood and you're there,
Yeah, but you're smelling 24/7.
Yeah, but
so there are things which you would then describe as something hitting your memory are like peaks on smelling, while the other
it's the special stuff.
Yeah, the other 23 hours you just smell. You need to breathe which is kind of funny. So you can't really shut down your odor detection.
With visual perception, there's this thing that things need to move for you to be able to see things. Is that the same with smell, that you only perceive new stuff?
Yeah. There is a study where odor, which is smelled for a long time, I think about 3 or 4 minutes, does not get perceived really anymore. Yeah.
Let's talk quickly about the political dimension of these forms of recognition, because in the image recognition, it's one of the most talked about topics right now in terms of technology and society and surveillance.
We need to talk about how it does what it does and why and what the problems are, in short.
And we believe very strongly in images. So we believe that what we see is what it is, and we believe that what the machine detects is what actually is.
Yeah.
And we hand over a lot of this detection, but also the process of detection and the interpretation and analytics to machines. So in the end, we get this kind of executive report on what is going on. So we move like everywhere in technology in the last, at least I have seen it in the last 25 years, we kind of move away more and more away from the source, from the actual thing.
There's this analogy to make with the invention of photography. The argument was really that this is scientific. There's no way people could inject subjectivity, their preconceptions into it, because it's the machine that does the photo. And obviously it's all completely wrong, We all know this now. It's like if you look at photos from the 1800s, they're completely full of the same sensitivities and bias as all the paintings and the sculpture and all the other stuff, the cultural products of the time. With AI and recognition systems, we're making the same error. I think it's kind of neutral, and because it's the machine that does the recognition, it cannot be wrong, it cannot be subjective. It's totally amazing.
But it's totally different in the field of odor.
I didn't get where you see the difference, because I think that in a second, when people start to write algorithms which detect odors or anything out of it, there will be the same biases.
Yeah, but they don't yet.
No, they don't. No,
that's
sure.
what I mean. That's
but
the
will.
Yeah, they will.
They
yeah.
will, because
yeah,
and I think there especially will be super heavy biases in there, because odors are not talked about. So that's the thing.
There's no words.
Yeah, at least in English and German.
Yeah, you said this before we started, that, because the people who encode these things, they're usually white men, and they say, I don't smell, but everything that smells different is smell.
Well, at least I think with everything, as so often the main perspective is a male one, the perception also of how people smell is that white politicians or other people who are that much in the center do not smell, and everyone else on the periphery or everyone else does smell in some form. Yeah, that was nothing I came up, but it's a quote, but yeah.
Women smell, migrants smell, poor people smell,
old
people smell, really nasty.
You said that.
Yeah, sure I did.
In comparison to all other senses, the things or the signals coming from the nose do not go through the filter of the thalamus. In fact, while some visual signals do not enter your brain, every odor signal enters your brain.
How wide is the spectrum? Auditively, we know which frequencies we can hear. Visually, know which spectrum we can see. How is it with odor? Do we know? Can you explain how it works?
Not so good. These are mainly numbers. Or to me, these are numbers. So I didn't understand it yet. But in comparison to almost any animal, we are super. There isn't even this word for people who don't smell. So, one funny thing, one anecdote, which is kind of funny, is speaking about the aspect of gender in odor or how people smell, is that in 1770 there was a law against witchcraft, which was in Great Britain a law for women not to use too much perfume or not to smell too good, because this was easy to be seen as
manipulating.
Yeah, too manipulative, but in a sexual way.
It's really difficult to talk about it because we lack the language, we lack concepts, we lack the understanding. So I think it's really amazing that you work in the field because it's pioneering. A friend of mine, Robert Jelinek, that was amazing. I was in the UK a few years back and they showed an old movie, which was a smello movie. It's super, super, super basic and primitive. You just have a movie and then you get a card, and then on the card there is an instruction that the moment this graphical symbol, like a triangle or a circle, appears on the screen, and it would come really prominently like in the middle of the movie, then you should scratch and sniff on the card, and then there would be a relation between the smell. But it's not working at all in a sense. Yeah.
Kind of the pioneer thing for VR is the sensorama, and there's also the smell of pizza to be smelled inside the sensorama. But this goes back to the 19th century when, like, I think even in Brave New World, Aldous Huxley wrote about the piano which produces odors.
So for me is always a question of the interface, because everything I see right now doesn't really work. I'm not happy with it. I mean, the acoustic stuff works quite nicely. You can do amazing stuff with spatial 3D sound with simple headphones. It actually works, and you can do it with €20 headphones. The VR stuff is okay right now, but it's not far enough. We know the augmented stuff, it's going to take years and years to get it closer. But in the end, I think we have to go into the brain. What do you guys think? How do you want to deliver the smell?
There is already an object called odor, which is given to people who suffer from dementia. Mm-hmm. And in the morning, midtimes, and in the evening, it only has to diffuse very few kind of food, and people start to remember to eat. So people who suffer from dementia really gain weight.
It makes them hungry also.
Yeah, it makes them hungry and they eat. And this is one good example.
I like speculation. What are hypotheticals, dystopias, utopias, neutral visions for the future in terms of odor and the combination of other senses, or even something else that comes along, in terms of networking for the image recognition and the way you work with images?
I think that, and this is definitely a negative perspective, is that when it comes to writing the same algorithms, just with a database of odors or odor data, there will be the same biases to be found, like which there are in algorithms which describe visual things. I'm 100% sure. I think the first one which might come is because Apple has the patent of detecting glucose level of a skin, or right at the skin. I think that might be found in new Apple watches. Might take some while, but I think that wearables which already exist will be added. They're little e-noses will be added. And artificial sniffers, because we had this word, artificial sniffers. Yeah, that's the best word for electronic noses.
I'll try to wrap something up, because we talked about this report on a new paper on adversarial examples, where I think it's mostly vision detection systems. I'm sure there are others. People are not sure why these exist. You just add little bits and suddenly the algorithm sees something entirely different. You can fool it. And there's a new theory. You give the detection system just images of cats and dogs, and it says this cat, dog, dog. And then you can still fool it if you change, I think, even just the pixel structure of the cat, and to the human eye it would be the same. To the system, it would clearly be the other thing. And if I understand the paper correctly, is that in the training material, there may be, even in the images of cats, a lot of dogginess that is really there. It's just that we can't see it. So there's a lot of things in the physical world, and it even gets captured on photos, but we're blind to it. It's just like a real blind spot situation. And the computer vision system doesn't have this blind spot. And they see it, they detect this other bits of dogginess in those images. And that's why it says it's more likely that this is a dog. And then I got thinking about, okay, there's maybe so much things that we don't see maybe consciously, right?
I believe we do have these antennas, but because the world is kind of, can be a very harsh place, a very brutal place, we have to firewall ourselves off. We have sensory systems that do firewall because they have an experience, because otherwise, for example, Asperger children, they're completely overwhelmed by auditive and visual and tactile input. So they have to basically artificially reduce that because they have no good firewalls, but other people have it. But I think in the opposite, for me, it was LSD to open it up. But I think we all have this capability. I'd like to go a step further and look at the whole thing more like from an organism point of view, to say, okay, we're living as new organisms. We are new animals as networks, and these new animals have new sensory systems. They don't only have smell and taste and auditive input and visual input. They have different existence levels and different forms of collaboration and working together, and different entities that are bound into one. Yeah, so this was the part of the Octopus about recognition with Stefanie Glauber and Christian Sievers. Thanks for listening. This was from the KHM, the Academy of Media Arts in Cologne. Brian.
Yes.
Hi, nice to meet you.
Very nice to meet you. Yeah.
Welcome to the Octopus. We're really happy to have you here. You are part of the setup with two other artists we have been talking about. That was Stefanie Glauber. She's an artist and she works with odor. And then there was Christian Sievers here, who is an artist who works with image detection. The general topic of this podcast is recognition. Explain to us a little bit about the application you wrote about image recognition for plants with diseases.
My name is Brian Muhia. I am a machine learning engineer. That means I work with data scientists and I work with other software developers to build and implement the infrastructure surrounding the projects that we're working on, like as far as it concerns machine learning. So that means I train and I test machine learning implementations. So when I was learning how to do this, I worked on a project. I decided I chose for myself a data set and a project to sort of train myself. And this data set was called Plant Village. Plant Village is a community that basically crowdsourced the creation of a data set of diseases from researchers all across the world, including from Kenya. They used very high quality cameras, and mostly from high-end smartphones, and also very high quality still cameras to generate over maybe 50,000 images that were then annotated according to the disease type and the species. And what I did was I just trained a model on it, or someone who has a smartphone can just take a photo of a plant and then it lets them know what disease is affecting the plant, and then use published records to get information about what someone could do about it.
What kind of machine learning technology did you use to be able to do that? Where are the challenges in doing that?
I used a technique called deep learning, a newer version of that technique called transfer learning. There's a problem that's which basically caused the revolution in deep learning called ImageNet. And ImageNet is a collection of maybe 1.5 million pictures of houses, people holding their pets, people holding their dogs, people who have caught fish, cars, plants, everything. The problem is to classify those 1.5 million images into 1,000 categories. This took a very long time for people to figure out, but around 2012, a group of people figured out that they could build a kind of a model called a convolutional neural network. The first of its kind, where the team actually figured out the right way to train a convolutional neural network, won the challenge, and that model has been replicated ever since. The way this is done is by slightly modifying the original and training it again on a new data set. The challenges are entirely about equipment, right? So the equipment used by the researchers and the farmers to get the data was completely different from the equipment that I expected to be used by the farmers who are going to be trying to use the application. Mostly because the types of lighting are very, very standardized in the dataset that I used. It's very even. It's probably overhead lighting with very little shadows, and the only shadows that come in are shadows from the leaves themselves on a very flat, clean floor, which is a completely different environment from what would be seen. Someone is outside in a farm taking pictures of a plant which is still on the of a leaf, which is still on the plant. So this is a problem called domain adaptation. The domain in which the pictures were taken that created the original dataset is completely different from the domain in which the application is meant to be used. When you train a machine learning model in the way that I did, you basically have a very fragile, very limited kind of recognition. It only gets to see one side of things, and it doesn't have any way to use what it's learned and conditionalize its predictions on the other side of the world, the side of the world that hasn't been exposed to. So this, in a way, it's more like a historical artifact rather than a dynamically changing technology. And even if I retrain the model by getting new data, say I take 1,000 new photos and using my phone or using other people's phones, the kind of phones that those people have, together with combined with the training method that I have, it will basically slightly expand the domain in which the model will work, but then it still won't be robust to new kinds of domains.
Is there a model where the machine can learn to understand the world on its own terms and maybe be able to communicate with humans and explain to humans how it perceives the world without having to perceive the world the way the humans see it?
I think in 2014 or 2015, a group of researchers in Montreal were having a few drinks, and they were trying to solve the problem. They were discussing on how to solve the problem of getting a computer model to generate images of the world that looked realistic. And this field of research is called generative modeling. The problem they hit upon was that you can't do it because the model doesn't have enough context about what the world looks like. One of the researchers figured out that you could build a sort of game where instead of training one model, you train two models to compete in sort of a competition where one model is trying to fool the other model, and the other model is trying to detect whether it's been fooled or whether it's seeing images from the correct dataset. This technique is called generative adversarial networks. This kind of training is very, very useful. It turns out that you can actually do that. You can generate very accurate, very realistic kinds of images, especially more recently with advances in computation and advances in training methods. Now, other than the adversarial kind of things where two kinds of models are competing against each other, there's a way for models to tell us which part of the dataset it can use to make the prediction. And the way this works is by, say, when you're classifying an image, when you're looking at a picture of a dog, a model can tell you which parts of the image look most dog-like by showing something like a heat map around the image. So that's one way that a model can explain its decisions, because it's using the image itself as the source of the information, which means it can actually highlight which parts of the information are actually important to it.
What kind of projects you're working on right now?
I have two projects that I'm working on. So one is to try and figure out how to generate sentences from images in an African language. I think I'm going to work with Swahili for now, because I know Swahili. The way I'm doing this is by crowdsourcing the translations of about 900,000 sentences for a challenge that was done around 2015. What I'm going to do is, once I get a set of translations for these sentences, I'm going to go through the internet and find as many Swahili sentences as I can find, and then train a model of the language. This will be done by basically training a model that can predict the next word in a sentence. Once I do that, I'll be able to transfer the model's knowledge of Swahili to the problem of generating sentences from the data set that I'll have crowdsourced at the time.
What is the reason for you to do that? What is your intention with it?
My reason for being interested in natural language processing from the African language point of view is because the size of the African data sets that people can use is very, very small. So I want to see how much one can do with the data sets that are available to basically just someone whose only access they have is having plain access to the internet. I want to have advanced the state of data sets for African languages with the crowdsourcing website that I built. I know Swahili it's much more well represented on the internet. There are millions of Swahili speakers and writers online, and they actually do use the language, but it's much smaller than English. Like if you look at Wikipedia, which I have, the data set for the English Wikipedia, as far as the sentences are concerned alone, is about 6 gigabytes. But Swahili is about 800 megabytes. What I want to see is like what it would look like for someone in a much worse position than I am in, as far as data sets are concerned, to actually accomplish that goal. And also, I want to see what it looks like for a model that can generate sentences in Swahili, and trained only in Swahili, not trained to translate.
So this maybe leads me to like a conclusive question in terms of technology and the influence of technology and also the origins of technology, because a lot of the tools we use and a lot of the platforms we use are American made. Mm-hmm. They come from the Silicon Valley, or they're made by people who are oriented towards these areas, and they're using the logic that is being used in this country and the logic of machines and platforms and the operating systems, programming languages, etc. How far are you feeling that you're completely depending on this infrastructure, and how far are there initiatives or also like just practicalities in using own technology or technology from different countries, from China maybe, or Russia, or other African countries? How does this play out, and what is the actual situation for you, and what is your take on this issue?
Okay, that's an awesome question. I've actually been thinking about this problem because there's a kind of a trade war happening between the US and China, and it's actually caused near economic elimination of one company, Huawei, from actually selling products to people. And it's going to have effects. So the trade war is going to have effects in a lot of things, including the hardware that people actually develop for their own purposes from scratch. So what I'm talking about here is open source hardware. For me, the way I see power going to people, the best way to do this is by promoting open source software usage, building open source software communities. But the problem isn't just about software; it's about hardware as well. I think one of the best ways to accommodate this is by figuring out how to build an electronics industry or a technology industry that doesn't depend on specific geographical locations. The day-to-day things that we are trying to do almost all depend on the kinds of technologies that 50 years ago would have been unthinkable. And to continue that, it looks like we'll have to continue building massive corporations that have a very huge lever, but then their decisions are extremely opaque. The physical hardware of an i7 processor is ridiculously complicated, and that knowledge about how it works or about how each component connects with each other component is very arcane, and it's very rare, and it's basically some of the most valued secrets on the planet. And it basically means that we are building like huge economies on very fragile grounds. The fragile grounds are now the secrecy and the trustworthiness of the companies that are building the technologies themselves. We're in a situation where very few organizations hold the keys to the galaxy, and the entire planet is actually just depending on them to keep their act together.
Thank you. Yeah. That was great. This was the Octopus about recognition, Erkennen. I thank you for listening, and any kind of comments, any kind of contributions are well. We're happy. Yeah, thank you so much. Thank you, Brian.
Thank you for the invitation.
Yeah, thank you.